Okay, we've seen how to decide whether a string matches a pattern, but how do we use that? How do we go from that to being able to actually pull out meaningful data? Just asking if a string meets certain criteria can be helpful in some cases, but it doesn't really solve the overarching problem we started with. And so what we want to do is talk about not only ways of deciding if a match exists or even going and searching for matches, but actually once we have a match, how do we decide what parts of that match are useful to us and then extract them? So the first thing is we can use just the match function. We've seen that there are these other functions that might be helpful, but just the match function can help us a bit with this. A match function decides, yes or no, does this string begin with something that matches this pattern? And it returns this object if the answer is yes. So in this first example here, I call the match function, and it does return an object, which means that it found a match. But the way the pattern is currently written, I could use this string, which I've omitted because it's too long. This string will tell us where was the match found, and this also tells us it's characters 0 through 45 of the string that was input, but it won't tell us interesting things like, hey, where did this quantifier get matched? The sequence of 0 or more digits. Whereas down here, I'm using a feature called grouping, which allows me to tell the regular expression parser that there are I'm writing a pattern to try and find something to match a piece of text, but inside that piece of text, I don't care about most of it. It's mostly there for context. I just care about pulling out these interesting pieces of information. And notice that I use brackets for that, and we'll see in a few minutes that we therefore are going to have some problems because we often use brackets for other things as well, just for regular grouping, not just for specifying a sub-expression to extract. So the parentheses operator actually has two different functions, which is it's used to create sub-expressions. So for example, that case from earlier where I wanted to match multiple words. So that would be one or more word characters, then a space. And I can match 0 or more words in a row by putting the whole thing in brackets and sticking a star on it. We often use brackets for that purpose so that we can stick a quantifier at the end of a sub-expression. But brackets actually have a second purpose as well. When you put brackets in a regular expression, you are telling the parser that what ends up matching inside those brackets is significant to you. We typically call this a group, even though I know the word group is pretty general. A group inside a regular expression is the set of characters that ends up matched inside a particular set of brackets. And so a sub-expression or a regular expression with no brackets would have no groups. A regular expression that has any sets of brackets would have more than one or more groups. And so in this case, I'm defining 3 different groups, these 3 sets of brackets. And if I perform the match, I can then ask the match object for its set of groups. And it returns this tuple that would be the contents of each group in order from left to right. So the contents of the first group was this, then the second group was this, the third group was this. This is immensely powerful because it means I can write the regular expression to sort of tell the parser what kind of thing am I looking for, but then in the same line, I can tell it what information inside of that do I actually care about. And I can be pulling out just these numbers from this bit of formatted text. And I could easily then convert them to floats and work with them just like I'd read them in from any other source. So the number of groups you're going to get will always equal the number of sets of parentheses lexically in the regular expression. And wait, what's lexically have to do with this? It turns out that there are cases where you can have brackets inside of brackets. An example would be something like, how about this sub-expression? So this is going to be 0 or more occurrences of AB, followed by the letter C. And that can repeat 1 or more times. So here's a string that might match that. ABC, AB, ABC, C. So notice that because of this being quantified, the first thing is going to be ABC, the first one of these large terms. Then I'm just going to see AB, ABC, and then I'm going to see a C by itself. So what I have here is brackets inside of brackets. To be clear, the number of groups in this regular expression is 2. I know that, yes, each group gets matched more than once, but the number of groups that you get are equal to the number of pairs of brackets in the actual string of the expression, not the number of times something gets matched. That's what I meant by lexically. So the number of groups you get is equal to the number of pairs of parentheses in the expression. So in this expression P1, I've got, let's see, one group there, one group there, one group there. I should expect guaranteed that if this pattern matches, there will be 3 things in my groups when I'm done. Down here, I am trying to match, it's actually a pattern to match the same thing. If we look at what P1 is doing and what's in my input string, I've got 3 of these terms, td/td, td/td, 3 HTML table cells. And I'm matching them with P1 by just writing them all out from scratch, and then matching in the first one a bunch of characters, and then a bunch of characters in the second one. And of course, if we're in Software Engineering 265, we like automating stuff, we like condensing stuff down, and we think, wait a minute, if I'm just matching 3 identical things, is there some way I could make that into a sub-expression? Well, yeah, you could try. How about something like what we have in P2? In P2, I'm saying here is one table cell. And then use the curly bracket quantifier to match that exactly 3 times. The problem is that would match. We can see it does match my input string. It does actually match this string, which has 3 table cells. But if I wanted to extract that data, it wouldn't do it. Because when I extract with groups, the number of groups in my result equals the number of brackets in the pattern. And this pattern contains 2 sets of brackets. That's it. So you're going to get 2 things. When the group gets quantified, which is what's happening here, so because of this quantifier, this sub-expression could match multiple times. When that happens, the thing that you capture is the last one that it sees. So what it's doing is it's matching this sub-expression, and then it's pulling out these numbers, but then it's seeing the next one over, and so it's matching this sub-expression, and it's pulling out these numbers, and then it sees the next one over, and then it matches this sub-expression and pulls out the word overcast. And we notice down here, when I look at the groups that come back from P2, that I only get the text inside the groups on the last match of the quantified group. So there are limitations to what I can extract using groups. The way that quantifiers and grouping interacts can often result in conflicts like this. It turns out that there is actually still a remedy for this. I could use re.findAll or something to still use the condensed version, but I actually wouldn't use the quantifier in that case. So there are still ways of avoiding having to copy and paste your pattern over and over again to match something repeatedly. But to use basic grouping, you can't necessarily use a quantifier and expect the groups to come out the way you want them to. And so then the question is, if I want to use groups, and I'll explain why that's significant in a couple of minutes. If I want to use groups, how do they get numbered? So there are, the number of groups I end up with will be the number of brackets in the pattern. But if I care which group comes first, so for example, I notice that this is apparently what comes back first in this expression, the groups are numbered by their opening bracket from left to right. So the group that gets opened up first is considered to be the first group. And the group that gets opened up second is considered to be the second group, even if it's inside the first group. They're just numbered left to right, starting by the order of their opening brackets. You can actually use the group's contents inside a regular expression using the specifiers \1, \2, \3. And I'll give an example of that. So what if I try to match this? Match me a word, that would be one or more word characters, followed by, I don't know, a space, let's just write \s, followed by the same word again. Well, notice how this is grouped because there's brackets. What I'm going to say is I'm going to use \1. What this is telling the regular expression parser is, I want you to match a bunch of word characters, so here's some word characters, then a space, and then \1 means match the same thing that came out of group number 1. Well, this is group number 1. So an example of something that would match this pattern is this string. So the same thing twice. So you can actually use the contents of a group you've already captured in the same expression that you captured that group by using \1, \2, \3. That's a bit weird, and the performance of that tends to be a bit slower than the performance of normal regular expressions. This notation is, however, also really helpful if you ever want to do a substitution, which we'll get to in a few minutes. So there's this function find all. Unlike re.match, find all goes looking inside of a string, and the string could contain all sorts of stuff, and it goes looking for any matches of the pattern inside the string. Now, to be clear, it does look for non-overlapping matches from left to right. So if two matches overlap, it doesn't take both of them. It only takes the first one from left to right, in left to right order. So in this case, if I want to pull out the HTML table cell data, what I could use is a pattern that just matches one cell. And then I could use find all to go give me all of the non-overlapping occurrences of that pattern inside of the big string. So I can solve that issue I had earlier with having to repeat a table cell by using find all instead of match. If I then want to go and extract data, I can use grouping along with find all. So if you use find all on an expression that doesn't have any groups at all, so this one here doesn't have any brackets, so it's not a grouping expression at all. In this case, what you get is just a list of all of the occurrences of the pattern. That's it. If you use find all and there's only one group in the pattern, this pattern has exactly one group defined. What you get back is a list of the contents of that one group for all of the matches. In this case, I can therefore extract the data with actually a pretty simple regular expression. Notice that I'm able to, in one fell swoop, not only match the stuff I want, but strip away these TD tags that are in the pattern to make sure that the parser knows where to look for them, but I don't need them in my result. So by using grouping, I'm able to omit them immediately. This is what I just said. If you use a pattern that has multiple groups defined, and you run that, and you run a search using that. So here is that in that human readable data from the first example, and here is a pattern that matches one instance of that. And if I use find all, it'll just return each line because I've matched each line. What I want is the data from each line. So if I add groups, notice that now my pattern contains multiple groups. It has 3 groups. If I add groups and find all is used on a pattern with more than one group, what it returns is a list of tuples, and each tuple contains, so this is the first thing, and then this is the second thing. Each tuple contains the contents of each group in each of the matches that it finds. So it's finding all matches, so it could find more than one thing. For each thing that it finds, it gives you the breakdown of the contents of each group. Okay, and then one more issue. Because of the mixed usage of brackets, because they're used both to define capturing groups and just to define sub-expressions, because of that mixed usage, there can be conflicts. And so an example here is, this is I would like to match any word, let's see, the word rain and the word plane here. So if I just want to match any word ending in AIN or containing AIN, what I could do is use find all to match any word characters, AIN, any more word characters. Okay, and so then I get rain, Spain, mainly, and plane. Okay, if I just want to match the words rain and plane, I guess I could try something like this. I could say, okay, match either an R or PL, and then match AIN. Okay, that looks good. This is an expression that would work for that purpose. This would match any word that begins with rain or plane. The problem is, because I wanted to use the OR operator, I had to put it in brackets. And because I put in brackets, if I use find all, it assumes that I meant to do grouping. And so it only gives me the contents of my groups, which are just R and PL. But I wanted the entire match. I wanted the word rain or the word plane. So what do? Well, what I want is I want all of the sub-expression benefits of brackets, but I don't want to define a capturing group. And Python has an option for that. In your brackets, if the first 2 characters are question mark, colon, what you're telling it is, I want this to be just a sub-expression group, a non-capturing group. I better fast forward here. So I'm using a non-capturing group, which is a way of using brackets that have no effect besides to define a sub-expression. So they don't result in capturing happening. You could still have capturing groups in your expression, but this one is not treated as a capturing group.